and when we will show this file to the fabricator, to the workshop, to the worker, he will be easy, like it will be easy for the workshop worker that to know how the design is made, how the design is working, everything. So and the best thing about weldments is that uh, it contains all the standard things like the pipes, the option of pipes, the option of square pipes, the option of beams given in weldments are the standard one, like which exist in nature, which exist in our market, which exist in our workshops. Like it is an international or standard, we can say, dimensions given in SolidWorks. So let's begin. We will be beginning with a sketch just on a front plane, and let's suppose we want to make a kind of beam for our car chassis. We make a line. Let's suppose this is our a kind of line, a simple line. This is the length for of which this is one length of one beam of our car chassis. So let's begin to weldments. In the weldments, you just first finish the sketch. Our sketch is ready. Then go to weldments, and there is an option structural member. Just click on it. Now there is a drop down menu which contains standard, type, size, and groups. What is standard? Like standard is the standards of dimensions used in a word, like ANSI, NSI inch, AS, BS, CNSI, DIN, GB, ISO. Mostly use people mostly use ISO and ANSI. These are the mostly standard used in Pakistan, or like mostly international standards are these. So we'll be using standards. And the next is type, like what type of beam you want to. Let me show you. There is a drop down menu: angle iron, C channel, pipe, rectangular tube, SB beam. I will be showing you all. Let's begin with angular iron. This is the first option. And the next is size. Like now we will be giving the size of angle iron. Like what should be the size of this beam? There are these three sizes are the standard given in the market. So these three are available. But if you want some kind of you want to make by your own, like you want to launch a new kind of angle iron, then you have to do it by yourself in simple 3D modeling. And next is group. Like this is the way, like these things are easy. Standard, how to set standard, how to set the type, how to set the size, these things are very basic. The next and the kind of complicated thing is grouping. Like this, I just made a single line, single straight horizontal line. This is easy, just select on it, and this is how it's done. Like see, the angular beam is made. It's very simple if their line is just a straight line. But if the line is a curve, different curves, then it will be have a kind of difficult. I will show you all the types of beams or weldments available here in SolidWorks. Then I will show you some different kind of curves for your easy. This is the beam. Like mostly these are used in roofs. Mostly these are used in supporting the chassis or body of some vehicle, some mechanical device. These are for sports, to support our design for increasing its endurance. This is the basic, like this is the angle iron. And now we will be changing it. Now we will change it with C channel, the shape of C channel. Now select the size. This is the size. This is also used, mostly used for making chassis and to put supports. Like if our body is a kind of weak, then we put supports, and we use this as a support for our chassis, for design, for bodies of different vehicles or like that. This is another kind of weldments available in SolidWorks. Let me show you clearly. Like C channel is just a kind of mirror of the angular beam. And the third option given by SolidWorks is a pipe. It's just a basic pipe, like circular pipe. We can also design this through features, as I mentioned you yesterday. There is an option swept boss base. Through this option we can create this. Like first we have to use swept boss base, then we have to use a kind of shell option to create this pipe. But in that at that case, we have to decide inner dimension, outer dimension, all things by ourselves. We can do a mistake. Like these are the standard, these three sizes are the standard given by SolidWorks, standard available in the market, standard available in the international market, standard available for engineers, standard available, like this is the standard, these are the standard used by engineers to design a new thing. So that's why we use weldments and sheet metal. And next thing, let me show you the final product. This is a pipe, and the next thing is rectangular tube. This this is also used in manufacturing cases of our robots or our mechanical devices. I will be showing you some models which is using this pipe. And for endurance of this pipe, we use that angular beams inside it, outside it, like used in weldments, just to support, like in 90 degree, a kind of 90-degree L shape to support our beams. uh, this is our product, like we use this to create a standard design. And the next option given by SolidWorks is SB beam. Let's see how does it look. This uh, we can we can add materials also, but I will be telling you how to add materials at the material part in the next hour. And the next option, the last option given, is square tube. Like rectangular tube and square tube are same, but the difference is just a shape. Like rectangular is a kind of rectangle and square is a kind of square. So let's change it to a square beam. Like square tube and rectangular tube are same, just there is a difference between the dimensions. Like these four dimensions are same, and in the other, the dimensions are a bit different. These are our weldments, and now if we want to see some different options in the weldments, some complex structures of the weldments, we will be looking for them. uh, any scale plane. And now our design is a kind of this thing and this thing. Let's increase a little bit, make it horizontal, and there is one more line here. This is are a bit like this line is easy, but if for weldments you will find some you will having be difficulty to design this. Let's suppose all things are good, make it a kind of square tube. Okay, size is this, and now see, if I will select a group, it will just design this only one line. So I have to make this whole beam. The other just you have to click in the group. But if you find, like in one group I have added all three lines, but sometimes we got difficulty to add all three lines, then we have to make new groups. This is the line. This is our let's hide this sketch and see. This is our product. This is the pipe mostly used in chassis making of robots, and like line following robot or anything. These are mostly used in aluminum pipes. Let's change it a little bit, like change the sketch. Wait, let's delete the weldments so we don't have any issue. Now we are having a bit more difficult thing. Let's see this if it got some issue. See, like it's easy. We just have to add a group, and then we have to make it like this. But there is, like, we can change its shape also. Like we can select the joints. Like see, the joint is, see the type of this joint, and we can change this joint like this. We can change the joint like this. We can change the joint like this. Like this is how it's welded. Like if you want to make this joint separately in fabrication, like this is the benefit of weldments. if you, this is like you can show your worker, you can show your fabricator that how you have to make this. Like if you just want to bend the whole pipe through bending process, you have to select this option. This is a kind of this is showing like from here, from one line and second line, the line, this line and this line is just bended, and the third line is welded. And now we can show our worker like the way of bending. This is one way of welding, this is another way of welding, this is the third way of welding, and this is the another way of welding. Here see the details how it's welded. And let's change its shape to pipe. See, if we will change the shape here, it's a bit easy. Like it's easy for you to design, it's easy for the fabricator to manufacture it. So weldments, let me repeat it again. Weldments and sheet metal are like, you can design these things in 3D, just simple 3D modeling. But why you choose weldments and sheet metal? Because it makes you easy to design, it makes easy to fabricator to understand the design, it makes a fabricator easy to fabricate the design. So these are the reasons why we choose weldments and sheet metal. In the last session, I showed you how to like why sheet metal is beneficial. Because when you design it in sheet metal, in the end you just flatten the surface. It shows to the fabricator like how to cut the shape through a sheet metal sheet. And now we can see, like we can show our fabricator how to bend our pipe, how to weld this pipe. That's why this is called weldments. And let's design a kind of chassis type of thing, like a base, top plane. Let's suppose we are designing a kind of upper part of a boat or like that. Let's suppose this is our like the hull of a boat. Let's suppose we will add some more lines to it. uh, First we will try to design this. This is our basic sketch. Then we will go to weldment, structural member, and then we will select pipe. We want it to be a circular pipe. Then add a group, new group, and see, this is how it's done. Like, see. And if I want to make a sport here in the bottom, here in the bottom, I can add this, I can add that also. Let's delete this weldment so we can design it this through a single weldments. To repeat a command, you just have to enter it. Like let's suppose I am drawing a line, and to exit the command just escape. Then I want to I want to draw a line again, then just press enter. See, the line is again made. And this is our whole, like we want this type of structure. Just go to weldment structural member, and then there is an option groups. I will be showing a bit, like a bit kind of let's see, square tube. Square tube was a bit small. And then group one. And see, like the first sketch was a group one, and now try to select second. Like it can't be selected. We can't select the second one. Just create the new group. For the next sketch, create a new group, then select the next sketch. See, This is how it's done, and it automatically shows how to weld this. We can change this option also, but it's good, like it seems good, but we can change it. We can change it through here, but it's like it doesn't seem good. We want this, like we want it a kind of waterproof, should be no holes. So this is how it's done. But let me show you, like if you want to create only one sketch, what you have to do, just delete this, go to 3D sketch and just select this all sketch, convert entities, convert all the entities. Let's select it from here, sketch 1, sketch 2. We have converted all this into a 3D sketch. Complete it, then hide the 2D sketches. And now let's try to design this scare tube. Now group 1, see, this is our one plane. There is a bit difference here. Like there was a kind of like it seems a bit more clean if we use 3D sketch. Then again group 2, and like for one plane, like if for every plane there should be a new group, because the plane is changed, the model of the plane is changed. Like the upper body is plane in a top plane, and the lower body is designed here in our front plane. The lower body is designed in front plane, the upper body is designed in top plane. So that's why we have to use different kind of different groups for weldments. There is a bit change in the shape. Merge bodies, you can merge bodies from here, and then see, like first this pipe was a bit turned. We just add the alignment, like everything should be alignment, like all these things. Like if you are working with the weldments, you will be enjoying the vibe of working in a workshop of welding or bending or like that. So this is our weldments. That's it, I guess. Yeah, everything is wait. There are something more we can add in the weldments. Handicap, goes it like let's see, like if you want to support these two pipes, like the two perpendicular pipes, we will add just a gusset here. See, as in preview, let me zoom it. Like this is the support you are adding. We can uh, reduce it, reduce the size of it. That's good. And now from face here also, see, you can add anywhere. And you let's add it in the front. We want to add it here, here and here. It's not possible because there is a new body down there. Just did here. Now you can add it only between two perpendicular faces. See here, and again enter it, cause it. See, this is to support our structure, to add an extra endurance to our structure. And there is one weld beads. This is used to show the weld marks or like that. And there is a one chamfer. I mentioned this thing to you last yesterday. This is just to add a kind of chamfer. Let's reduce the size. Let's add it to 1. Now it's not possible to make a weldment here, so just leave it. This is our weldments. You can extrude cut is the same, extrude boss is also the same. Trim extended, like if there is an extended object from here, like it can trim it for you. There is no extended from here. Like if I will select this, it will trim the whole body. There is no extended faces here, so there is no use of trim feature here. So this is for our weldments. Now, what's the next topic for us? The next topic is 2D drawing. 2D drawing is also a standard, also helpful for fabrication, also helpful for us to show the fabricator how to design the how to fabricate it, to show the manufacturer how to fabricate it. Like if you are doing for mass production, like it helps the manufacturer to design, to manufacture your design with exact same dimensions, same angles and everything. In 2D drawings are some detailed drawings, it shows how deep the hole is, everything. So first we will design a kind of wait, I have closed the slides. We will first design a kind of complex like which contain holes and everything. Then we will make its drawing. I will show you, I'm telling you the way how to make 3D drawings, to drawings of our model. First you have to model your design. Let's suppose we are using the front plane, we are making a kind of sheet or like that. This is our design. These are a bit holes, like one hole here and one hole here. That's it. And then extrude it, just 20, 40. That's it. This is our design. So just add a bit more features here, make it a bit complex. uh, Corner. This a bit more, making it a bit more complex. uh, so let's suppose this is our design and make a kind of hole here also. Use the center triangle. That's it. Extrude cut. Make it 10. That's our design. Like let's suppose this is our design. So now we want to make a kind of technical drawing to show our fabricator how to design this. So here is the option, like go here you can see there is a home option, and beside the home option there is a new page. Just click the drop down menu, there is option new, there is option make drawing from part and assembly. Click on it. Save the file. We will save the file in our desktop. Just save a file. Then here, like now we are entered to the new interface of drawing. I will explain you the interface also. I will explain you how to select. Like first of all we have to select the sheet size. What should be our sheet size? It depends on the parts of your design, like how much parts it contain. It depends on the size of your model. It depends on the standard your company use. It depends on the standard your country use. So we will be using A4. Our model is a bit yeah, like there is a little bit model. And the next thing is you can use custom sheet size. Like there will be nothing. Just click custom sheet size. There will be custom sheet size. You can add weight, height, anything of your own. I will show you. Let's show it. Here you can choose the sheet size of your own, like will, what should be the size. I will be using standard A4 size, ISO standard. Let's enter it. Now we are entered it. Here on our right corner, it's showing our views of our model, like how much model we want to use. Mostly people use top, and then this is our top, this is our side, and there is three views are enough, and this is our isometric view. I have added all the things, and now I will, like this is my master copy. I will just click on it. Let me explain again. This is how we add our models. Like if you want to delete some view from here, we will have to just click. There is a option on right side of our screen. There is option of view palette. Just click on it. There are all the views: front view, right view, back view, top view, bottom view, isometric view, current view, everything. everything is present here. And like if you want to change a view, if you want to change like it doesn't shows our holes and everything, just click on it. There are some views of it here. Like if you want the details of holes, chamfers, everything, then just click on here wide. See, this is showing me like this is showing there is a cut here, this is showing there is a hole here, this is showing a hole here. I can make it a bit more detailed. Uh, like this the next thing is like the models are kind of large for me, so I can just resize it 1 by 2, it's 1 by 2. I will just do 1 by 3. See, like this is how you can scale your drawings. And now I want to rearrange it, just click on it. Like see, this is how we rearrange our model. And now like you want your isometric in a 3D view, just click on it, change its view to it. Like see, mostly people hand over the 3D drawings in this. And the next thing is like how you will show the dimensions of your model, how you will show the dimensions of it. There is an option smart dimensioning, just click on the side you want to add dimension. Let's suppose this, like just click on the line, the dimension will be automatically added. Like how our 3D UI knows the dimensions, it is totally linked to the dimensions we used in our 3D model. Like if I will change something in the 3D model, the drawing here will be automatically changed. That's the benefit, that's the easiness. Yesterday I explained reason efficient in 3D modeling, that's the reason. Like this is also a reason why it's efficient. You have to change there, automatically it will be changed here also. That's the easiness for you. You can there is a one more option here. uh, See, wait. Like you can define things like what is this or like that. This is also a feature here in your 3D in your technical drawing. You can add dimensions, you could add angles. See, you can add angles here. You can add different angles. You can even add like how your dimensions should look like. I use this style. You can change the style of your dimensioning. See, this is the dimensioning styles. There are a lot of dimensioning styles here. This is what I use. Wait, this is the style I mostly use. You can change the arrows, you can change everything. And now like you can also add mark balloons. See, you can change the balloon also here. uh, Item number, like you can add a text or everything. Like if you want to add remarks, add some kind of symbol or that. And the next feature 2D drawing gave us is table. You can add bills of materials. Let's suppose select the drawing view to specify the model. This is our view. Okay, now there will be bills of materials here. We can add it. And we can add the center marks. See, have you seen the difference? Let me do it again. uh, Center mark, like there is a circle, but maybe people think there is just a cut or like that. I will add a center mark, so the fabricator should know that there is a hole. I will just add the center line here. And from here, like it's already done here, I can add here also. See, there is a center mark here. That's it, how is that it is done. And the next and important part is how to design this, how to make alteration in this. Just click here. There is an option tables. There is an option annotation. From there you can add text here, you can add insert box here, everything. But if you want to edit your sheet, there is the option, just right click on it. There is an option, edit sheet format. And there is how, like let's suppose it's not part 4, it's our part Delete on it and go to annotations and add note. It's part practice. This is how we will add it. Uh, part 7, part 5, part 7, part 1, anything you can add here. You can change its place, anything. And now you want to add the title here. Just SolidWorks Workshop. You can resize it or anything you can do. See, you can place it anywhere. And if you want to add dates, name, drawing, anything, you can add here. Just add materials here and go to annotations, notes, material, and here we can write it steel, iron. Iron is our material. You can add anything. This is how our sheet is. We can edit our sheet design or anything. Let me show you again. Just click anywhere on the screen and then right click it. There is edit sheet format, and when you go to sheet format, everything is like the drawing is gone. You can't change the drawing. You just have to do your work here. And whenever wherever you want to add some text or like that, just click there and right click it. There is a option in the drop down menu, annotations. Go to annotations, then go to notes, and you can add it anything. You can even change the text of it. You can even change the text. You can even change the fonts. You can add the size, anything you want to change in your own standard thing, in your own standard, like the standard used by your company. Let's add some more dimensions here. See, it automatically identifies what shape is it. You can add the depth. You can add anything here. See, anything you want to add, you can change the view. You can change the view. We are view like this is a view of the SolidWorks standard. Give us these 1, 2, 3, 4, 5 different views. This is the shaded with edges. This is just shaded. This is hidden lines removed. Like there is no hidden line in this view. All hidden lines are visible, and it's only wireframe. So we have just selected hidden lines. See, all hidden line are shown. This is for easiness of your manufacturer. And you can save your 3D your 2D drawing and in different for file formats. Just go to save as. There you can see it, you can save it as Adobe Illustrator file. You can save it as a PDF. You can save as drawing, SolidWorks drawing. You can even save it as DWG and DXF. If you will save and if you will save your drawing in these two formats, you can edit it even in AutoCAD also. And you can save it in a picture, and everything is given. You have a lot of options to save your drawing. That's for the drawing. Next is assembly. Let me see if I can explain some more things. Balloon is, I have mentioned, like you can show you what part is this. Like balloon is mostly used when you are making a 2D drawing of assembly, a complex assembly. Let me see if I can show you any. Uh, Let me find if I can show you any complex assembly. See here, this is the complex assembly. See, like this is a complex assembly. I have used the balloons. These squares are, these circles are the balloons. I have mentioned like I have marked every part, given a number. I have given every part a number. And in this is the bills of materials. Here I have mentioned like there what is the quantity of the part, like how much. See, there is a bolt, which is, what is the number of bolt? 5. Where is number 5? This is number 5. These two bolts are used here. So number 5 is a bolt, and there is a two quantity used is 2. So this is how we use balloons in our 3D in our 2D drawing of a complex assembly to make it easy for our manufacturer. That's it. That's it for our 2D drawing. We can add different dimensions here. That's it. This is it for our 2D drawings. Now we will use the same part as assembly. Like, what is assembly? Assembly is an option given to us. Like, we our design is of not a single part. We can create it in a single part, but like, how we will explain our manufacturer, how will we will explain to our fabricator that this is not a one part. There are a lot of parts in our design, so we use assembly. Like, we design every part separately, then we import them in our assembly, SolidWorks assembly, and then we combine them, we assemble them, and then our assembly is created, our design is made. Let's suppose in these holes there are two motors attached. Let's see how much dimension of these holes is. Make it 20 so it will be easy for me. Okay, these holes are 20, so I will be using two motors here. And what's the dimension of this? Make it also 20. And length is, okay, leave the length, uh, 82. Okay, this is our design. Now we will go to the home. Again, we will design a new part. Top plane, we what our circle diameter was 20. That's it. And now we will extrude it downwards. Just make it 20. 20 is good. And for your convenience, I will add a mark so you can see there, like, it's moving in our assembly or not. uh, Convert its outer body, then use this. Make it 15. Like, you can, so you can able to notice like this part is moving. Save it here in our desktop. That's it. And there is one more part which is the was 20. Another part, design another part. Again, top plane, it was 20. Make it 70. So can I can explain some more mates in our assembly. Okay, extrude it, just 10. That's it. Save it, desktop. Wait. Now we will design our assembly. Again, like, how we will have to make an assembly. We can go in two ways. First way is just click on home, then go to assembly. And the other way is just click here, like, the go to the same option from where you go to the drawing, just click on this drop down menu, make assembly from part and assembly, just click on home button. This is very easy. We now we are entering assembly. The assembly UI is completely different, like it's totally different from the part UI. uh, this is our, oh, we have selected the parts. Go to here and assembly. Now we have entered our assembly UI. This is our assembly UI. Like first I will select all the parts from here, and this was my first part. Like this is the part I haven't clicked it. This is not no, this is not present in our assembly. Now it's in a floating, like I have to fix its position. So like I don't want to be like this in this shape. Like it should not face towards me, the top of it face towards to the top angle. I can change its position after placing it, but I want, for my convenience, I want it before. Like I, if I want to face it, like give a 190 flip. So which axis I want a flip? I want a flip on Z axis. Just click on Z axis. Like this is how I want to place, but I want the bump on the left side. Now I will give a flip on Y. See, this is how I have placed this, and the next part is here, and the next part is here. Now, like always remember, whenever you are importing parts in the assembly, the first part you import is always fixed, it is not movable. I will show you. Let's see. If I will click this part, I can move it anywhere in my assembly workspace. I can move it anywhere in my assembly workspace, but I can't move this part because see the notification in it, the selected component is fixed. uh, the select wait fixed, and it can't be moved. So if I want to move this, I have to right click on it, like click the part, right click on it, there is a float option. If I will click the float option, then this part also be able to float like the other part, but I want it fixed. This is my source part, this is my reference part. But the next problem is I want the two copies of this. One option is like you have to recreate it, the other option is to copy it, the third option is to import this part once more. But for me, just press Control C, click on it. See, a new part is generated. Control, put your hand on Control C, and then click on this part, and the new copy is generated. See, this is how, like if you there is a lot of objects used, same objects used many times in an assembly, just copy it. And if they are in a pattern, so just use a pattern, as I mentioned you in part in 3D modeling. And now I will do my assembly. Like I have imported all the parts using my use it in my assembly. Now I will show you how to assemble it. uh, First we will assemble these motors. Let's suppose these are motors. So what should be, like how it should be assembled, this face is going to be attached to this face, this face is going to be attached with this face. And I didn't like this is not as much deep as this is. So this face is going to be equal or at same height of this face. So these are the two mates. What are mates in SolidWorks assembly? The mates are a kind of, you can say, connecting or helping tools which help us assembling our different assembling our parts in our assembly. So go to assembly, there is an option mate, just click on it. Here, c- like select the two faces which are going to be connected. And mostly 99%, there are 99% are SolidWorks make the assembly correct by itself, make the mates correct by itself. There are a lot of mates and a lot of types of mates. Like there are a standard mates, advanced mates, analysis, and mechanical. We will be using standard, it's the basic level. And there is a mate coincident, parallel, perpendicular, tangent, concentric. I guess the now, like, I will not select the mates. SolidWorks automatically will be using the concentric mate for this face and this face, and the for top face it will be using coincident. Why coincident? Because I want to be fixed. Like, I don't want my second part move move out from the hole. Why? Because this is the motor. If I want to move out from the hole, I will use parallel. Like, the upper face of the my second part will always be parallel to the first the face of my main or reference body. But I don't want that. I just want the concentric and coincident, and you will notice SolidWorks will automatically do it. Let's select this face. If you select a face of a body, you will notice the body is now not usable. This body is now inactive because I can select only one face and then the next face. See, now see the difference. Now my body is movable up and down, but it can't move left and right. Why? Because this face is now mated with this face. And let's see the mate. As I told you, SolidWorks automatically selects the best possibility. And so it's concentric. Now I want to fix this movement also, the up down movement also. I will select this face, go to mates, and select this face also. See now, as because of concentric, it can rotate. It cannot go up. It cannot go down or like that. But there is a shortcut. Like, if you don't want to go to mates and select the planes, I will control C. My second mate is finished. There is one more shortcut. Like, if you want to work like save your time, just click on all faces which you are going to mate. I will click this. Keep pressing the control key. I have control key, then press the second face, and then right click on it. Like, all this time my finger is in control key. There is an option here, mates. Just click on here. It will automatically select the best mate. See, it said selected the concentric. Just click on this tick, this tick. Everything is done in more easy way. Now I will mate the second one. Good. Now this face and this face done. This is all. Now I will use this here. And first I will explain you which mates are gonna be used. I want this face to be fixed with this face, and I want this part at the middle. Like, I want this part should not exit from here and there also. But how can I do? Because this slab is a bit shorter than this length, the part of the length of our reference. So I will be using some advanced mates for this. First I will use the basic mates to place it, this face and this face. See, now it's placed over there. And what should be our next? Like, it is going here and there also, but it can't go up. See, it can't go up. So to fix its left right movement, I will fix these faces, this face, and okay, this face will be with this face. It's kind of over defined. Now my part will not go left and right, it will just go back and forth. I have to fix this, but I can't fix this. Like, I want to fix it. Like, I can fix this back and forth movement till this face and this face by using parallel mates, but I can't. Why? I want to fix here. Like, these face, I can't place the concentric because the faces are of not similar length. I will be going to advanced mates. Go to advanced mates. There is a mate of distance. This is the mate. Click or here. Click here, and here I will see. You will see the difference. 1 mm is here. I will place 2 mm. See. Uh, Wait, let me color this part so you can see the difference. Now we will be using the distance mate so you can feel the difference of it. Advance. See this face and this face. There is see there is 1 selected. I will increase it to 11. See, the 11 is selected. Now see the difference. My slab is not going to move from here because the distance mate is automatically it is fixes like it doesn't allow to move because the distance is fixed between this face and this face. This is how our assembly is done. It's movable, this is not movable, that's it. And let me show you some a bit more complex assemblies projects. These are a bit complex assemblies which I will be showing you this because I want you to explain some mates of the assembly which are used in the mates. So let me show you. This is our stand. The part which is in blue is now our stand. First part. The second part is my belt. This is the next blue part is the next part. The third part is these boxes. These three boxes are the same boxes. And there is one more plate. See, these are my plates. One, two, three, four, five parts are there. What mates I have used now? Like this is my fixed part, and like I will show you one more thing. Like if you want to check mates between this belt and this stand, just click on belt and then press the control key, click on the stand, right click. Here it shows view mates. It will show you the mates of your the mates which are being shared by these two parts. Just click on mates. See, all the mates are shown here. This is how, like if you are confused to see the mates which are being used by these two parts, like there are a lot of mates here. See, so you got a bit confused, so just select on the object, go to view mates, and you can see the mates. And now I want to the next thing is I want these plates to be movable around the belt. How I will do, I added a sketch here. See, let me unhide this sketch, unhide. I i added a sketch, like because I want my plates to move on this path. So what mate I will be using, I used let's select one plate, go to view mates. I added a mate of path mate. What is the path mate? You give a path to your body, like through which it will use to move. Like this is the mate, like it is bounded to that part. Your body cannot move other cannot make other movements except moving around the path. This is the path mate used here. And the next is like the next are simple mates. As I've shown you, see, let me show you. These are the path mates used by the all our plates. And you can add like let me show you where is our assembly. This is our assembly. This is the concentric. Delete it. This is my concentric mate. This is my this mate. Just delete it. Okay, now these are free. Go to mates. There is a multi mate. Select like this face, this face, this face. Wait, I like in multimates you can add different add multiple mates to the body. Like let's suppose this body is also attached like concentric to this body is also concentric to this. There is a third body which is also concentric to this hole. so you don't have to add one by one mates. Let me show you. This is our mate phase 1 attached to this, phase 2 attached to this. Like this is the first phase. All are attached will be this. Let me this should be this should be our first phase. And now, oh, this should be our reference phase. And now this is my phase, and this is my phase. See, these all are concentric to the same phase. Multimates are used, I'm repeating again, if there are a lot of bodies which are sharing one phase. Like every phase, there is a one phase in every body which is being mated to one single phase. Like, see, there are two bodies, two faces mated to this one single phase, so we will be using multiple mates. Why? To save our time, to make it easy. Like if I have to change this mate, I have to redesign it. So it will be easy for me to redesign it, to change the mates, everything. This is why, as I mentioned you yesterday, 3D like SolidWorks is efficient in 3D modeling or like that. So let's exit it. Like we don't want this change. Control Z. All mates are again placed. Mates, I will fix it. So I can use this same assembly in motion study. I can use this. I will be using the same assembly in motion study. That's why I designed this in the same way. And this is the part of our assembly. Now I will be showing some more things in our assembly. uh, there is, like, you can add one more assembly in another assembly. If I will save this, let's add some from my storage. Add insert a new assembly. See, there are options: insert a new assembly. Go to insert a new assembly. Oh, I have to save this one. Save all. The desktop. Save externally inside the assembly. Okay. Insert components. Browse. I want to add, let's suppose, this part here. See, I can add a new assembly here. I can add the mates. I can add everything here. This is how it's done. Like I can add one more assembly in an assembly. The next assembly will be called sub assembly. The total assembly will be called my main assembly. And now we will be going to our next part, which is motion study, materials, appearances, and rendering, simulation analysis. This is a bit long part. Before going to the module 4, let's go to the question answers. If there is a question for what I have explained it till now, you can I can see the comments. You can write it on the comment. You can sure mention in the comments. Two comments. Yeah, there is no comment till now. I will be waiting for just 1 minute. So if there is any comment about these, what I explained uh, about Weldments 2D drawing assembly, any question about this, kindly ask it here in the comments of the live video. No questions. So I will be going forward to my next module. There is module 4. Motion study, material and appearances, appearance, rendering, simulation, and analysis. This module is a bit important because, as an engineering point of view, simulations and why appearances and rendering is appearance and rendering is important. Why materials is important? Because, like, you have designed your model, but if you are not able to present it well, then what is the benefit of your design? What is the benefit your design is giving to you? Like if you are not able to present it well, so rendering is important because of that. For materials, like when you're doing simulations and analysis, when you're giving it to the manufacturer, material is important, so he she should know what material is used to fabricate this model or design. For motion study, like you want to this motion study is used like for yourself, it's for yourself, it's for fabricator, like to see how your model is working. I will be showing you how motion study work. Let's go. There is three tabs on the left bottoms corner, and there is a motion study. Go to the motion study. Now what is our goal? Our goal is to rotate these objects, rotate these two motors. So what will I do? First I will go to basic motions. This is included in basic motion. Then go to settings. I will set my frame rate. That's okay. All is good. And now there is an option here, motors. See the option, you can see the icon. It's just like the motors. And now here there are motors: linear motor, actuator, which is called actuator, and rotatory motor. I will select this phase. This is my counterclockwise movement. Okay. And what should be the RPM? I will select my RPM 100. It's okay, 100. And now I will add one more motor. This is the motor. This is also anti-clockwise, but I will make it clockwise. That's good. And now I will be going for calculation. That's now it will calculate. There is one mate which is making it difficult for my assembly to calculate it. uh, there is one mate which is wait, I will add it 50 rpm. And the body is this is the reference body, and the face is not our part 1. No, this is not my path. I will add face is that, direction is that, component direction. This is my component is that. Part 5. No, part 5 is not. Part 6. That's it. And delete the second motor so we can see whether it's working or not now. Frame rate good, geometric accuracy good, motion analysis good. And go to motion analysis. Just do it. See, our actuator is working now. This is how it will be working. And I will add my new motor here. And same, I will a bit slow, 25 rpm, so you can easily see it. Then again calculate. One is moving counterclockwise, both are moving counterclockwise. I will change the direction again. Motor 2, and change the direction to clockwise. Then again calculate. And now, oh, again calculate. There is an issue or motor 2, because let's remember one thing. Like I have paused my assembly here. Let's suppose it's 5 second. So whenever you are going to edit your assembly, just move the time bar, slide to the 0 seconds, then add your motor will be adding here. It's make it clockwise. RPM should be 25. And now calculate the assembly. See, everything is good and fair. That's how it's done, and same is with linear, some linear, like these are the basic things through which you manipulate your design. I will show you some complex things in our motion study, that is, wait, I will show you some more. uh, Geneva wheel. I will open a bit more complex part. This is the complex. There is some issue. Wait, open it. We will try to open it again. Open Geneva wheel assembly. Yes. Let's close all this. It's giving me some kind of error. We will open our assembly again. Like in that assembly there is just one motor, but if you will notice the motion of that part, there are a bit difficulties and it's difficult to understand. To make that motion possible, there are some different options in motion study, which will help you to attain that motion. I will be showing you that. Just wait for a second. Open wheel. This is our assembly. Just wait for a second. This is my assembly, and let me show you its motion. See, this is its motion. Wait. Uh, this is the motion, this was the motion of it, like with just simple motors. I will show you uh, a, a bit more complex motion of Geneva wheel. This is the same thing, same mates are used, but see the difference in the assembly. See, like there is just one more motor at, if you can see there is just one in the workspace of our motion study. In the bottom left corner you can see there is only just one motor add for it. Where is the motor add? Let's see. The motor is added here with the Geneva wheel drive. This is the Geneva wheel. This in blue is Geneva wheel, in the red color, and now it's selected as a blue. And the green is our Geneva wheel drive. So there is one motor add. Like why this is showing this behavior, this kind of motion, because of this solid body contact. Like when you use this feature, SolidWorks automatically identifies the solid bodies. Like let me reduce its speed to 0.25, and now I will be explaining. See, like it goes in here. Why it doesn't mix up? I will open the other assembly also, so you can make you can see the difference solid. contact, like what solid contacts does. This is the second assembly. See the difference. I will reduce its speed also. Here, see, it's going inside, like it doesn't, it is not working properly, it is going inside. Why? Because I don't have used, didn't use the solid body contact feature. I just used two motors, and in the other assembly I used the solid body contact. Because of this, like whenever they both get contact in this, it SolidWorks automatically stops one body or moves other body to avoid collision, to avoid mixing up. So that's why this motion is obtained, and this is the real motion of a Geneva wheel. Like I didn't add the key marks, this is not the key mapping. If someone knows the animation like that, this is not the key mapping. It's just the solid contact. Because of the solid body contact feature, SolidWorks automatically stops one body, moves other body, stops one body, moves other body. If I added the motor, the same motor with to the Geneva wheel, the motion will be reversed. I have added the motion to Geneva wheel drive. So whenever the body came into contact, SolidWorks automatically makes the Geneva wheel stop, and the Geneva wheel drive keep on rotating. So this is one other feature. You can add the key, you can add key mapping, you can add springs, you can add dampers, or all that. Dampers is the shock system. And you can add a map also. Wait, motion analysis. You can add a graph also here. Uh, Time graph, time. Okay. Mm, category. I want a velocity. Sub is linear angular velocity, and the third thing is a long uh, y-axis magnitude. Okay, see the difference. Like there is a bit. There is a bit. You can say a mistake in placing those two things. That's why the graph is erased here. See, the graph is erased here. Like this is the motion, then it came to stop because of the solid contact. Then there was just ignore this. And if there is again motion, because the contact was removed, then because of the solid contact it again came to zero. And then there is a speed. If I will make it in this place and assembly here, and now I will, if I will play my, see, this is how, like at this time it moves and then came to stop. This is the velocity of Geneva wheel, not the Geneva wheel drive. For the Geneva wheel drive, I will show you. For the Geneva wheel drive, it's a kind of continuous, because it's continuous. It doesn't came to a stop or like that. Angular velocity, magnitude, phase is this. Okay, this is for Geneva wheel. The straight line is for Geneva wheel. Why Geneva wheel? Because it doesn't stop, because we have added the motor to our Geneva wheel. And this graph is for the Geneva wheel drive. This graph is for Geneva wheel, the straight line, the constant line, and the curves is for Geneva wheel. Because whenever there is a solid contact, it came to stop. Like we are using help of these features to make it in a virtual way, but in actual way, you can see this. Whenever there is a solid contact, body automatically comes to a stop. So this is our motion study. uh, this is it. I have explained you how to add rotatory motion, how to add a linear motion, everything. If you I will show you an example of linear actuating motion. Wait, proximity. Just close these graphs. I will show you now example of linear actuating, and as I explained it yesterday, I will be showing the use of mechatronics, the designing of mechatronic system. So I will open it. This is like here. I will explain you the design first. Like here, this is the conveyor belt. It motion is just a rotatory motion. This is our sensor. This is our sensor. This part is our sensor, the one I selected in blue. This is our sensor, and this is my actuator. What is the functionality of it? Like whenever this is a proximity sensor, it identifies the boxes, like the small boxes. Whenever there is a small box, it activates the our actuator push it towards the other side of our conveyor. So let's see the motion study of it. First I will show you, this is how it's working. See, it identifies the like the height of the object and it activates my actuator. And if you want to see how it's going to activate, there it is. It's not a kind of visible. I will be showing one by one. Like this is how I am learning. I'm making my sensor to learn things. What is the commands my sensor is going to give? Task one. There are four commands run by my sensor. The first command, it alerts my proximity trigger is sensor. Trigger is my sensor, proximity sensor. What function is do? What's the first task my sensor is doing? It is alerting my actuator that now you have to move. My actuator moves, and the next task, my actuator stops at a certain limit, and then third task it actuator is going back, and now the fourth task is actuating is stopping at its initial position. See, alert. Now it will be it my actuator. This is my actuator. This is my actuator. It will move, and the next task it will stop at a certain distance, and the third task it will get back again. See that speed 1400 and minus 1440. Why minus that? It has to move back, and then again at the fourth task it have to came to a stop. This is how it's done. And this is the sensor. This is this at these two times sensor is activating. It's not key mapping, it's showing the sensor activation of my sensor, because there are two boxes. This is been accomplished, and now this will be accomplished. This is the use of mechatronics system in my design. This is the use of mechatronic system in SolidWorks. And what are the things I have used in it? Again, solid body contact, so these things should not mix up with each other. Rotatory motion of my conveyor belt, and there is one linear motion for my actuator. And I showed this design just to show you what's a linear motion. Let me show you again. See the motion of this. This is the actuating motion. This is the linear motion in SolidWorks. That's it for our motion study. Now we will be discussing about appearance and rendering. Let me find a good design so it will be a bit more interesting for ourselves. Uh, a bit easy design, so it should be easy to uh, mm, just select this thing. This is our thing. Like, let me explain you first what is the benefit of rendering, why we use rendering, what are the options for a rendering. We use rendering, like let's suppose I have designed this table. This table is good, well looking, but if I will show my client like this, wait, like this, is it attractable now? No, it look like it is not attractive. I can't attract my client, I can't attract my company. Like this is my design, and if I will show like this, This is the use of appearances and rendering. Like this, I have just add appearances, appearance and materials. I haven't yet render it. How you add an appearance in your model? Just go to here. There is a option here. See, it show edit appearance. Just click on it. Appearance, color, and there it give you option. Like if you just want to add a color to just one face, you will use, there is option of face, a surface, there is option of face, there is option of a complete body, there is option of feature. Like this is some extrude cut. Okay, this is an extrude cut. Here I will go to feature. This is my extrude. This is my extrude. It will just select that extrude. This is my extrude. It will just select next boss. See, boss extrude. It will just select the boss extrude, but I will not add it. This is how we use appearance to our model. Just click on it. You can add colors. You can add. There are a lot of appearances here. See, plastic, medical, metal, paint, glass. There are a lot of metals, and there are a lot of appearances. There are a lot of colors. But if you want to make a texture, see, I have made this by my own self. But like I have, you just have to download a picture, and then you have to go on texture. Like SolidWorks give you an opportunity to create a texture, from a picture. It automatically gives you an opportunity. So this is how it's done. This is the appearances, and like how I will add a material to this part. Like this is a wood, and this is a steel or an iron, and I will just go here, and there is an option here of materials, edit material. Just go to part, right click on it. There is an edit material. Just go on material. There are a lot of materials here. I will be explaining you this thing again of when we will study simulation and analysis, because there is a large part. Like this is so important, adding material so important. I will just click on any material, just apply it, just add different units and everything. This is how we use materials to our design. And what's the next thing? Rendering. We have done motion study, we have done materials, we have done appearances, and now it's rendering. You got two options. Like I'm giving a workshop of SolidWorks, so I will be explaining how to render while using SolidWorks. But there is an issue, or you can say problem. SolidWorks only use your CPUs. It doesn't use your GPU. Only Quadros GPUs are being used by SolidWorks. So if you don't have a Quadros GPU, so it will take a bit time for you rendering your model. And how you will go to rendering? Like there is a no option, you can't see anything here. Just click here. Like just go click it in this tab, right click. There is a tab down there, you can see render tools. Add from here, or just go to SolidWorks add-ins and load your photo view 360. Photo view 360 is the render engine used by SolidWorks. So just go to SolidWorks add-in, go to photo view 360, add it, and there you will see render tools. Go there, and from here you can set appearance. You can set the scene, background scene. Like see, I want my shadow to be a little bit, there should be a gap between my shadow and my model. I will go to edit scenes. I can i can change my shadow distance from my model, but I don't want to, uh, like I just want to fix it as it is. So I want to remove these shadows, the floor reflection. I can just remove it from here. And if I will be using some sort of back plate image, I can flatten my ground, I can there, I can add shadows. But now there is no shadow here. And I can add advanced. Like here I can change my ratio and everything. It's 800 by 800. And there is a like I can change the lightning, brightness, everything here in edit scenes. everything seems good, like a bit good. And the most important thing is, in rendering, is the most important thing from my point of view is angle, like how you place your object, how I perceive it. Like, I guess for me, this is the best angle, like which shows me this is the best angle, which shows me almost everything. See, here it shows the wood, here it shows the curve, here it shows there is one more plate down here, everything is shown. Like the angle is the best. The angle is how you are presenting to your client or everything. This angle is good. Here in the middle I will place it, and I can change like white plane. If I want white plane, there will be no shadows. This is good. And now here I want, like, I don't want to render it, I don't want to waste my time, I will just put integrated preview. In preview section I can see how my object will be rendered, how what will be the final result. So if you want to see your final result before wasting all the time, you can just place in press it integrated preview. Just press integrated preview. Now it will took a little bit time, and you can see the preview of your model, like how will it look after the rendering has completed. Just wait for a second. This is how it will look when my rendering is being completed. Okay, like it seems a bit good. I don't have to change anything. If the shadows are good, everything is good, then click it again, and it will exit you from the preview, and there is a final rendering option. I will click on it, and now my rendering is being started. See, my rendering is being started. This is being rendered. My object is being rendered. Everything is doing good, but I don't want to waste time in rendering or all that. Just click here. And I want to know you one thing, like if you want to just make a render and save your time, there is an option here which through which like here is render options, from where you can select the resolution. You can control like image format. Here is the image formats. There are a lot of image formats, and here you can select the quality. I have selected maximum. You can best, better, good. I have selected the maximum quality my CPU can support. This is the maximum quality. Like from here you can change your rendering settings and all that. And if you want to just render a little bit part na, so here, like this is the render region. Like when I entered into the render engine, this much part is being rendered. So if I just want to render this leg of my table, I will just reduce my render region to the leg, like this, like this, and only my leg will be rendered. You can I will show you in preview section, like how it's shown. Go to preview section and see only this much part is being rendered. See, only this much part is being rendered. Next, the other part is not being rendered. Leave it. Integrated preview. This is how rendering is done. I will show you, like after I ended all my sessions, I will explain you some tips, some advices, like which software you should go for rendering and all that. But photo 360 is photo view 360 is also good, not that much bad. And it's a very good, like it is good when you're using for industrial use and for manufacturing use. But if you want to go for a like this is a mechanical and mechatronics, like this software, you can't use the render of this software for marketing purpose, for using brochures and for online shops. You can't use there, because like it for that, like it should more efficient or like that. But this software is, main purpose of this software is designing and all that. It's just an extra add-in given by SolidWorks to you, so you can render also, like, but the quality is good, like it's considerable. And our next part is simulations and analysis. This is a bit interesting part. Let's use this table. Let's use this table. Like I want to know, my customer says that I want to make does it support 10 kg of weight. I can I will say, like let me find it. I will just go into SolidWorks add-in. There is an option SolidWorks simulation. Go there. Like I'm doing finite element analysis here, like just stress, strain, displacement, and everything. Wait for a second. Here it's simulation, and I will select a new simulation. I will use static. Okay. Now this is the UI of SolidWorks simulation. Here you will first I will apply materials. Let's select just a random material. We are not making it an actual. Apply. Okay, it's done now. And now there is fixture advice, fixed geometry. Like my legs are fixed. This face and this face is fixed in the ground. Okay, and now there is an external load. External load is a force here facing in this face, and this is again SI English IPS metric G, and I will use like 10 Newton of force is used here, 10 Newton. Okay, this is done. And then there is a shell manager. Like now I don't have to do this, and then I will use to mesh my uh, apply mesh, create mesh. What is use of mesh gives your data to SolidWorks simulation, like how much compact this is made. Like there are some steels, there are some wood which is hollow from inside. If you will increase the mesh quality, it shows to the simulator of SolidWorks that this object is compact, a solid object. So I will increase the mesh quality to high. Okay, done. And now the mesh is being created. All done. All done. See, this is the mesh. This is of excellent quality. Now I will run the study. Now static simulation is being created. We have to just create for wait for a second. Now it is done. See, like if I will apply 10 Newton of force here, this is how it will be affected. This is the stress. Wait, hide me. Let me hide other things also. This is only hide. This was stress is let's we will show the effect of stress. This is the stress. This is the stress here. So this model cannot bear 10 Newton of force here. And now we will hide the stress. What will be the displacement here? This is the displacement. Like this area is the most weakest, the central area. And now we will see the strain. This is the strain here. See, stress and strain are almost same in this object. This is the plot which shows the color by color mapping, which area is more affected, which area is least affected, which is most effective. And we can also add some options here. There are like we can add some more results here. We can compare results here, like which we want to compare. Comparing results. See, all results are shown in front of us like this. If we want to study something, we will go to compare results. This is how we can compare our result. Like we can see the what is the strain, what is the strength of this model, how much it's been affected, and everything. This is the mesh quality, everything. If I will reduce, just check the wait, let me only show you. This is the stress. See, make it a bit, try to remember it. Now we will reduce the mesh quality. We will reduce the mesh quality to the half. Mesh, wait, mesh, uh, delete the mesh quality plot, delete it. Now we will add a mesh, create mesh. Yes. We will make it half. Reset, make it half, and this is our mesh quality now. And now see the results. The results are being totally different now. See, it is more bend now. It is more bend now as it was before. Show, see, it is more bend now. The graph is more bit like that. And if I will increase more phase, more force, it will be a bit different from here. This is how we do simulations. This is the finite element simulations, like static simulations. I will be showing you a bit more interesting simulation. Let me find it where I put it. Wing. Okay. This is an airplane wing. We want to see like what's the behavior of airflow towards it. We will go to flow simulation and see all our results. Oh, surface plot, trajectories, edit definitions, everything is good. Now run it. Okay. It will took a little bit time. It will took a little bit time because uh, I guess around. Okay, it's done. Okay, we will now go to surface plots show. Like this is the effect of wind. Now there are surface trajectories show. This will show you the behavior. I have reduced it. I have reduced it, like I have reduced the surface trajectory path so we can be able to see it more clear. This is the behavior of wind. If you want to play it, you want to see the surface trajectory, just play it. See, this is how wind will move in through our wing. This is how it's done. And now I will show you how we are gonna do this. Like I have already designed it because it took almost a lot time, and for you I will redesign it. Let's suppose right plane, not right plane. We will go to front plane, and we will sketch our design. As I mentioned you yesterday, from this we can change, control our splines. This is how my wing is gonna be. This is my wing. Now extrude it, mid plane extrude, and 500 length. That's it. Now let me close. Now we will go save it in our desktop. Now we will go for flow simulation wizard. Like let now I will show you how flow simulation is done. Go to flow simulation. If you can't find a flow simulation, just tab it here. There are tabs and there is flow simulation. Just click on it. It will load your add-in here. And if you don't know this method, just go to SolidWorks add-in. There is a flow simulation. Load it here. Some flow simulation wizard. Okay, next from here you will select the unit system. I have selected this. Next, and then like there are two types of flow simulation: external is for winds, for vehicles, or everything. For internal pipes, flow of water inside the pipes, so we are doing external, like it along the surface. What type of fluid we are using? It's a gas and it's air. Just add here. Next next and here we are going to add a bit like velocity, x-axis. It's let's suppose 35. Finish. This is the domain, like where the wind is being blown. This is domain, there is no big deal with it. And the next is we will add goals, like are going to add a surface goal. We are working with surface, like we want to see. Surface goal means like you where you want to see the behavior of wind. And we want to see the static air pressure and force along y-axis. Why we want to see the force along y-axis? Because when the airplane is moving, there is a push from below, wind push, which raises our plane. So we will be facing these two, noticing these two things. That's it. And now if I will start this thing, it will take a lot of time. First I will show you which results we are going to see. Surface plots to see the effect of temperature and pressure on the surface. Just go to surface plot and select the surfaces in which you want to see the behavior. Just contours, like we want to see in the contours, just click on it. And then we want to see the surface trajectories, insert it. And from where the wind is being blown from the right plane. Just this is the place from where wind is being blown. And that's it. Now we will run our study. I am like just pray so it can complete it a bit fast. It took a lot of time for flow, mostly for flow simulation. For static simulation, it doesn't took a lot of time. It will took a lot of time, like almost 15 minutes. No, it's still calculating. Yeah, it will took a lot of time here. So this is how it's done. And when everything is like the calculation is done, I just made a new calculation for you, so I can show you how everything is done. uh, this is the model we studied early. Let me open it again. This is the part, like after everything is done, the calculation is done. Now I am showing you the results. Run. It will take a little bit time because it's already being calculated. It will just take some seconds. Solver is okay. Now results. What are flow trajectory? So this is my flow trajectory. Like when I have shown you the all the method how to do a flow simulation. When the calculation are done, just go to flow trajectories, just make it show. Go to surface plot, make it show. And if you want to see the trajectories moving, go to and play. And if you want to save your animation, go to the animation and save your animation, and you can show it to some person or like that. This is how a flow simulation is done. And now our four module is alhamdulillah completed. Now I will any question, if there is any question. uh, okay, I got a question. What is the pros and cons of using SolidWorks and Fusion 360? It's a good question. I like Fusion 360 is the only software which is giving which gives a bit, a bit competition. But modeling is good. Fusion 360 is a bit more easy. You can say the things are a bit more easy, like a way more easy. Like if we want to compare, it's like a student of 12th grade and a student of 6th grade. Like the things are easier to 6th grade, and in the same way Fusion 360 is a bit easier. The things are openly placed each other, but it's not that much in deep. It doesn't allow that much deep functions or all of that. And renderer of Fusion 360 is a more good than SolidWorks. But when you talk about assembly, when you talk about assembly simulations, SolidWorks is top level. Like if you want to see the pros and cons between it, this is the main thing people choose SolidWorks over Fusion 360, because there are a lot of softwares which allow you to render. There are like keyshot everything. So the main difference why people choose SolidWorks over Fusion 360 is that assembly of SolidWorks is good. Like when you go in the engineering field, when you go to the field, assembly matters. Part doesn't matter. Like whenever you completed a part, then you have to import it in assembly and create assembly. So assembly of SolidWorks is more good than Fusion 360, because it gives you more options, fastening tools, everything. Like you can use solid assembly in the way you are doing it in real. Like you can place the threads, you can make fastening tool, like how it's done, how it's being done and manufactured in real. That's the benefit of SolidWorks assembly over Fusion 360. That was the question we got. And now we will go towards useful add-ins. These things are, a good thing. What is the power surface? Let me show you one design. What things we can make from power surface in SolidWorks. This is the rock. This is designed in SolidWorks. No one will believe you if we will show you this. This is the design made in SolidWorks. And the next design is this one. This is the thing made in SolidWorks by uh, power surface. Let me show you the option. Power surface is here. This is the power surface. This is the power surface. These are the options. And this is a next level thing. Like it can took 1 hour to explain the what is power surface. PhotoView 360, I've already mentioned it. PhotoView 360 is the render engine of SolidWorks. And the next thing is computer simulation technology. I show you two types of simulation. You can add vibrational simulation. You can do a lot of simulations in SolidWorks. I have shown you flow simulation, static simulation, which is also called finite element. And there is SolidWorks CAM. You can also do CAM in SolidWorks. What is CAM? Computer aided machining. Like this is when you are generating G codes or M codes for your CNC or like that, or for your 3D printer or everything. Like whatever you are generating, you can do it through SolidWorks CAM, computer aided machining. And the best thing which helps me a lot is Keyshot plugin. What is the benefit of Keyshot plugin? It's a plugin, yeah, like SolidWorks is also installed, Keyshot is also installed, but you don't have this plugin. You have to save your model, you have to import it again in the Keyshot, and then you have to do it. And when you have made a change in your model, you have to apply all the appearance of the materials again in the Keyshot, because the file is totally changed. But if you have Keyshot plugin, let me show you. Like if I have designed this, I have made a bit changes after my simulation. I noticed like this angle is not good, this curve is not good. I change this curve, but I already imported this thing into my Fusion 360 through imported this to my Keyshot plugin through this plugin. See, send to Keyshot 10, update Keyshot 10, export to Keyshot 10 files. I have sent this to Keyshot. Let's suppose I have sent this to Keyshot and I have made changes. Then I have to just click this button, update Keyshot. Automatically, all the changes will be made in the Keyshot. And the best benefit of this tool is like whenever, like let's suppose I have made a kind of motion study and I imported my software to Keyshot without this plugin. There will be no motion study. There will be no motion. There will be no animation in that assembly. But if I will use this plugin, my assembly, my motion will also be exported to Keyshot. That's the benefit. Let me show you a animation of it. Wait, just wait for a second. uh, as I showed you this assembly also, but see the animation. This is rendered in Keyshot. This is rendered in Keyshot, and see the difference of the SolidWorks and the Keyshot. That's it. Like you can do it anything with this plugin. That's the next beneficial thing for us. And the next thing is points, some points to ponder, some points to be careful when you're doing working in SolidWorks. Always be careful about sketch plane. Like let's suppose, as I mentioned you yesterday, like you are using in front plane, but the normal plane is right plane, and you are drawing in drawing, but it's not drawing in the right plane, it's drawing in the front plane. So it will cost you a lot if you are not careful about the sketch planes. And the next thing is assemble separate when prototyping. Like let's suppose, as I mentioned you, in this assembly, like I have used these two parts. If I will pattern these, I can still use it, but I'm using it for prototyping. Like, let's suppose my client says like there is a bit change, then I have to redesign it again. I can't change the linear pattern. I have to delete the linear pattern. Then I have to make it again. So if I will do, I will waste a little bit time and design separately at things separately. Then when my client, like you are working for a client, you are working for a company, and there is a change, there is a revision. It will be easy for you when you are assembling separately. You are not using shortcuts like fastening features or like that. And the next thing is use standard features when prototyping. Like when you are going for prototyping, as I mentioned to you, fabrication and manufacturing, then always use try to use weldment sheet metal. But like if you are manufacturing through molds, you're manufacturing through 3D printing, then you can use anything. You can use 3D modeling, anything, mesh modeling, anything. And when you are designing an object, leave some room for your modification. What does it mean? Like I'm using this design, so the dimensions I'm taking, the references I'm taking, I have to keep this thing in mind. Let's suppose I have to change the space, then what I have to design it again. If I doesn't leave this room for a modification, if I keep on references from the border edges, and let's suppose I have to delete my border edges, then what will I do? I have to redesign my model again. But if I will take the reference with some other things from the vertex, then it will be easy for me to redesign, to remodel my thing. And the last thing is work smart when modifying model. Like let's suppose I'm modifying my this part. Like this is the line, it deactivates all the things. Like only this thing is activated like this. Work smart, don't work like you are you redesigning the whole project again, whole design again. Just work smartly to reduce your wastage of time, to reduce your work or like that. These are the devices and points to ponder. And that's it of to 2 days SolidWorks workshop. If you have any question, I'm still waiting for your questions. Your questions are just in front of me. And what's the difference between the freelance potential of both applications? Like in there's some difference between what we can and what we can't do with them. This is a question with a freelance point of view of both applications, SolidWorks and Fusion 360. Like we can do everything with it, but with the freelance point of view, both softwares are easy, both softwares are good in the freelance options. But Fusion 360 is now, like nowadays, companies are inducting it, but mostly a large number of companies are using, industries are using SolidWorks. SolidWorks is a industrial grade software, but you can find a little bit more work of Fusion 360 maybe in some platforms. And what's the difference between like there is no difference between these software. Both are used for CAD, both are the working is same, but mostly people demand solid bodies for manufacturing. So SolidWorks is the only software to create solid bodies. There is some other softwares like 3dx Max, 3dx Maya. Those don't create a solid bodies. Solid bodies are only created in SolidWorks. That's the benefit. And we can't do anything. Like there is nothing we can't do with these software. As I created, showed you something like I have showed you my design of a sofa. See, who believes like this is created in SolidWorks? There's a rock thing. like ledge thing made for a client who want to feed his reptiles. See, who says this is created in SolidWorks? These are the benefits of both softwares. But there is a like, if you don't want to use some other kind of render engine, then Fusion 360 is more good, like because it uses a good render. Its render engine is good, but there are some other options. Keyshot is the best render engine used for bits alongside of SolidWorks. And with freelance point of view is a bit different than actual industry point of view. Like, I've been working in the NCRA, robot maker lab of NCRA. So the experience is totally different from the experience on the Upwork or Fiverr. So this is the main differences or applications of both softwares. You can design models, you can design machinery, you can design furniture, you can design everything with a practical, with keeping this thing in practically, like you are designing this thing and you are damn sure that this thing, it can exist in practical. But in other softwares, you can't do simulations, you can't check your design. Like, as I showed you a design of a table, like it can bear 10 newton of force and or not. That's the benefit of these two softwares. That's it. Thank you for all. And if you still have any questions, any queries, if you need any help, this is my Facebook and Insta page, Cat Guru 2.0. This is you can find it in Facebook and Instagram. And this is my email. I've also sent these slides to the student body. You can take these from them also, and the recording is also available. So thank you from my side. If you got any questions, you can ask till the session ends. Thank you and Allah
Thank you,
Hafiz.
Zafar. Zafar, we have got a question here from Mr. Abdul Kabir.
Yes, sir.
And
Yes, sir.
how efficient are the simulation results, structure and flow, especially mesh quality when compared with ANSYS?
Sir, one thing more, as SolidWorks has given a lot of options in one platform, so NCS is a specific software designed for simulations. So it's sure, it's 100% true that in simulations, SolidWorks NCS is more good than SolidWorks. But why then, a new question arises, why SolidWorks has added simulations in its software? Because like it gives you a general idea. Like, as I done a simulation of a table, it gives me a general idea that whether my table is good or not. But it is good. Like, there is a little bit difference. And mesh quality is a bit mesh quality is almost same. I've used both softwares. Mesh quality is almost same. But NCs give you a vast option of mesh quality. And the next thing is, there is a little bit difference of some extent, some points in not in all type of simulations. In some simulations, like flow simulation, there is a big you can feel the difference of flow simulations in SolidWorks and in NCs. This is the difference of between NC simulations and SolidWorks simulations. Another question?
Okay, I think that's it from the question session. Thank you, Zafar. It was a thorough lesson for all
Allah
of us.
Hafiz. Thank you.
Thank you. And thank you, everyone. Thank you
Thank
for
you.
having this. Allah Hafiz, everyone.